At first, let me remind you some technical stuff. As usually, you can ask questions during the whole session. You can see a panel on the right, and please, if you have any questions, just enter the question into the message window. We will answer them after the practical session. My name is I'm sorry, now you can also see my screen. Today we are here with my colleagues David and Philip. They will show you practical part of the session, and today we would like to show you something about also modeling of 3D geometry, but also about joint design resistance. This is very useful feature which gives you information how far your design connection is from the limit state, and in fact how big is the reserve in the design and how safe it is. And the second example is about beam link. We will show you import from Tekla Structures into IDEA Connection for this typical 2D frame connection of column and beam with two bracings, and we will show you some tips and tricks for your effective workflow. The webinar is recorded, and we will send you the record in 3 days after the webinar, and after the webinar you can ask for a trial version. Just put yes, no in short survey, and we will send it by email. Now let's start with the practical part. I will give presenter to David, and we will start with the first example. Davide?
Hello, everybody. At first, let me show you what we will do in the first part of our webinar. We will show you how to model 3D general joint, like this one. After that, we will tell you how to use joint design resistance. How does it work? How to work with the results. And finally, we will show you workflow in IDEA StatiCa for joint design resistance. So let's begin. Let's launch IDEA StatiCa. Open application connection. And here we create new project by clicking on the button New. In this table, we select code and material as S235, and we select topology of the joint. In the next step, we select again topology of our 3D joint. 3 beams were automatically generated, as you can see, and now we can proceed with defining geometry. At first, let's change length of column to 600 millimeter, and let's change cross section of column. We won't use general cross section, not cross section from the library. So let's click on the button Insert New Item. Here we go to Welded Composed and General Steel Cross Section. editor for general cross sections appear, and now we select the cross section which we desire. The first part is from I section, HEB 600. And then we can add the second part. So let's click on the plus button. And now we want TCAT from the profile HEB 500 and confirm. Now we change position of this second part and we use it for this table. We set master comp as the first profile. We change rotation and insert point, and let's shift it a little bit. Now we can use copy function. It is here in the upper ribbon. So let's click on it, and we redefine only one parameter, rotation, to the opposite side. Our general cross section was created and we can confirm. We switch back to IDEA StatiCa Connection, and as you can see, column is created with this cross section. Now we can proceed to the second member, member B1. We set cross section to HEB 280. That's it, and confirm. And we change pitch angle to -6. Yes, that's it. And we can continue with member B2. Here we change cross section to HEA 180 and confirm. And we change alpha rotation to -6. Yes, that's it. Now we won't add new member. For this operation, we use button Add New Entity. So let's do it. We change beta direction to 180, and we change pitch angle to 6. And finally, we insert the last member. So again, let's click on button Add New Entity, and we select cross section as angle section 100/8 and confirm. We change only beta direction, and we set pitch angle to -40. And you can see how our connection looks like. For member M5, we change also model type to axial force and both shear forces only to prevent mechanism, because this member will be connected with only one bolt, and otherwise it could rotate freely. So now our geometry has final design, and we can proceed to design. So let's click on this button. At first, we want lengthen the column, so we add new operation, cut, and we redefine cutting plane to farther. Because on the top of the column we want welds, we do some place for them. So we set offset to 18 millimeter, and that's it. Now we can go on with connection of member M4. This member will be connected with end plate. So let's add this operation, and we select end plate. Now we choose bolt grade as 8.8 and bolt size as M20 and confirm. End plate was inserted, and now we redefine the member which we want connect. It's member M4, and you can see the operation appears. We change thickness of this plate to 20 millimeter, and we change some dimensions. So from the top, 15, and we lengthen the plate. Now we change position of bolts, so we can go on and do it. So top layers minus 50, I'm sorry. Then left layers minus 40, and here we won't add some layers, so I will write more numbers, and you can see the bolts appear. And right layers we will set the same as left layers, so again minus 40, and that's it. Now I change only thickness of the welds to 4 millimeter for flanges and for webs, and we are using double fillet welds. We can proceed to connection of member B1, and to speed up the process we can use copy function. It's in the upper ribbon, here it is. So just let's click on it, and operation was copied. We change only few parameters, so we want to connect member B1, and we want lengthen the plate a little bit, and we add one row of bolts, and that's it. Now we can continue with connection of member B2 to the column. This member will be connected with fin plate. So we want to connect member B2. Connected part is web of this member. We change thickness of the plate to 8 millimeter and set some dimensions from top and from the bottom. For this connection, we won't change size of the bolts. So just click on the item, insert new item, and we change it to M12. Bolt grade will be the same, 8.8. And we switch location of the plate to the opposite side. Now we can see the plate, and I'm sorry, the thickness is too high. We change it to 8 millimeter. Yes, that's it. And we can proceed to connection of member M5. This member will be connected with cassette plate. So let's input it and let's change some values. So now we are connecting member M5 with new plate. It's related to member B1 and plate 2. Yes, you can see that the plate was inserted. Now we change thickness of the plate to 12 millimeter, and we redefine dimensions of the plate. We change the gap between profile and plate to 30 and alignment to rear. This connection will be done with bolts, so we change connection type to bolted. Now we won't change the shape of the plate, so let's click on the button editor and let's create, for example, bevel for H2 and redefine some dimensions. A 100 millimeter and B, for example, 80 millimeter. And we confirm the plate was modified. Now our joint has final design and we can load it. For do it, let's go to the load effects. Because this joint has many members, we can use function import. Let's open Excel sheet with prepared forces and just only copy and paste them back. Now our connection is loaded. Only for member B2 we have to change position of forces. I can show you why. We switch to wireframe model. We switch back. Here in this place you can see it's pinned connection. There is a hinge and we want there 0 value of moment. So I switch position of forces to bolts and you can see in this place now value of moment is 0. I can switch back to solid view and we can continue with calculation. Let's click on the button calculate. Non-linear analysis was started and we will see results in the table. Yes, that's it. You can see summary of the results for each part of the connection, and on the right you can see the picture. We called it traffic lights, and it tells you if some of the checks satisfy or not. IDEA StatiCa provides you various kinds of results. I will show you some of them. For example, you can display stress, strain, bolt forces. You can see the mesh or deformed structure. It provides to you bill of material with drawings. These drawings you can export to the XF file, and we provide for you 3 types of report: one line, one page, and detailed. And each of these reports could be exported to Microsoft Office file. So as you can saw, our joint was designed, loaded, and checked. But this webinar isn't only about modeling. Now I tell you about joint design resistance. It is function in a kind of analysis in IDEA StatiCa. Structure engineer usually solves their joint to design connection to design load, to transfer known design load, and you receive some results. Utilization ratio for each of the components. But it is also useful to know how far your design from the limit state is. So in other words, how big the reserve in design is and how safe it is. So how does it work? For this, we can use joint design resistance. User inputs design load as in standard design. Software automatically proportionally increases all load components until one of the checks doesn't satisfy. And user receive simple diagram and factor and ratio of design resistance and design load. This you can use for express maximum load. Now let's go back to IDEA StatiCa, and I will show you workflow for joint design resistance. So we have our joint, which we modeled before. Because we want preserve this joint, we go to project items and click on the button copy. The first Con1 is our first model, which was used for analysis type stress strain. And now our copied model will be used for stress strain, for joint design resistance analysis. It is this button. We switch it and go back to check. Now we switch the button calculate. It takes some time, so our model has been calculated before. I did it for you. And here in check, you can see that one new button appears, Join Design Resistance. In this window, you can see results for Join Design Resistance, only a simple diagram and vector. So let's summarize the results of Join Design Resistance. IDEA StatiCa provides as a result simple diagram and a vector and ratio of design resistance and design load. And you can use it to determine maximum load. For example, you can use it in many other ways. I did for you one example. We modeled this joint, this simple joint. Only two members are used and are connected together. This joint is done in 4 modifications. We used 2 bolts, 3 bolts. Here we add some stiffening plate on the bottom of the smallest member, and here it's welded. And now there is a question: which of the joint is able to transfer the highest force? I used Joint Design Resistance. Now I give you a few seconds. You can guess where is the highest force, but I think it is obvious. It is a very simple example, but good enough for our purpose. You can see that maximum of the shear force can be applied for connection which is welded. Then follows connection with stiffening plate, and after that connection with 3 bolts and with only 2 bolts. So thank you, and I give a word to Philip.
Okay, thank you, David. And I hope you see the right screen with the Tekla. And I'm here today to present an example and workflow from Tekla Structures to IDEA StatiCa. So we have a simple framed connection with 2 braces, and I can easily export it by the Europe flagged icon. I have integrated IDEA connection into the Tekla. Feel free to look up the steps in our website or in Resource Center. So let me start the command. Let's follow the instructions. So first instruction is to choose the node of the connection. The second one is to pick the connected members. So let me pick the column. The first one will be the supported member, second one, third one, and last. Hit the spacebar and just drag over all the components in Tekla. After hitting spacebar for the last time, the software will ask you for placement and the name of exported file. I click Save button and the model will be generated automatically. As you can see, everything has been defined as in Tekla. Structures. So I don't need to bother with the geometry. I can go into the load effects, which I will use from my Excel sheet, which I prepared in advance. So by the import button, just easily. And we omitted few things in Tekla Structures. It happens sometimes. So as you can see, these plates, connecting plates, are not connected to end plate and to the member 2. Also, these members are not welded properly. So let's just place a few cuts. At first, there is a cut of a member, and I see this is the member 4, and I want to see which plate this is. So just look on the bottom of the screen, and you see that this is a plate number 8. So I'll change the plate to number 8 by surface, right? And this happens sometimes. Yeah, and you see the welds are there. I won't bother with the size, and I will just copy this operation by the copy button, place it on the member 3, which will be cutted by the plate 16, easily like this. And now just a few more operations, and they are different ones because we will cut the plates. So let me choose the operation cut of plate, this one. And I will cut the plate number 11 by the plate number 7 by double fillet weld with the size of 30 millimeters. I will copy it and place it on plate number 17. And the last 2 welds will be at the intersection of plates with member number 2. So the brief copy by the plate of member number 2, and the bottom flange. The last copy will be for plate number 11, top flange, and we will cut by another surface, so by the top surface. Now we have done everything what was missing in Tekla Structures. In new versions, we will be able to transfer or update the modified Tekla Structures model. So we won't get rid of everything we made here. Now, after I inputted the load effects, I need to change the type of analysis, as the default one is the stress strain. So let me switch to joint design resistance. Just click the check and run the nonlinear analysis, which will gradually load the joint. And after a few seconds, we will see the results and the simple diagram as David described and explained. So let's wait a few more seconds. And in the meantime, let me encourage you to type some questions into our webinar. We will go through them in the end of the presentation. So the calculation will finish in any second, I hope. And now we can see that we could increase the loads by, let's say, 5.7%, right? So it is pretty much loaded even now. And this is all from me and a simple workflow from Tekla Structures. It is saving your time by defining the manufacturing operations already in Tekla Structures. And I will give the presenter back to Marek, who will guide us through another part of presentation.
Thank you, Philip, and also thank you, David. I take presenter back. Okay. Before we start with questions and answers, just let me invite you for the next webinar, you can quickly check our website ideastatica.com and webinars tab. You can see upcoming webinars. We have one next Wednesday, so you can already register, and you can also see past webinars, and you can access the records of all webinars. Also, if you are on this site, you can check the resource center, and you can find a lot of informations about IDEA StatiCa Connection, for example, tutorials and videos, all records from webinars are also here. So just check it and you will see. So now let's jump to the questions. Is it possible to export connection model into 3D CAD model?
Yes, of course. Let me show my screen. Or okay.
I give you presenter.
Yeah, I will take it. So now you should see the screen, and there is a bill of material menu. And then when we switch on the drawings, which can be seen on the right side, right there, these can be exported by the one button to the DXF file. Let's call it drawing number 2. And let's find it out on my desktop. Drawing number 2. And you see all the drawings of the plates, the bolt holes and stuff like that. And also I would like to show you the future possibility, and this possibility will be held on cloud. So if I go for our cloud solution, let me just sign in briefly. Let's just define some simple connection like this, and I can easily export it to 3D DVG file. So after a few seconds, it will be generated in cloud. It will be exported, and let me just give you a little heads up for the future. We are currently working on a free cloud weaver of your connections, and it means that you will be able to export your desktop models into 3D DVG as well. I'm not quite sure why is it not working right now, because it used to work pretty much easily. But currently we are really looking forward to have such an option.
Okay, Philip, maybe the next question. Does IDEA StatiCa check the codes, or is only based on the stress strain checking?
Okay, I will take this part. IDEA StatiCa have currently 3 codes. It's a Euro code, AISC, and Canadian code. The principle of CBFM method relies firstly in a finite element analysis, which enables us to obtain all the stresses and the forces in bolts, the stresses in welds and stuff like that. And then we apply these forces for the standard, it's different type of analysis. So let me just briefly make some dummy connection from the template, and it will be really fast. So you see it. I will apply the template, for instance, like this. And when I run the check, okay, the bolts are too close. Let me delete this row. I hope it will be fast enough. Yeah, and you can see that the code checks are done here. You can see the formulas which are according to the code, right? All the utilizations, all the factors, areas of bolts, same for welds, for utilization of the welds. And this is how the code is implemented into IDEA. It's everything like this can be also seen as a reference in the end of the report, a reference for specific tables and different codes, for instance, ETEC for anchorings.
Mm-hmm. Thank you, Philip. Just small remark. There is a wrong flag for Canadian code. We have US flag there, so we will.
Yeah, Tekla is now switched off. But yes, it's just some bug on my PC, but I have been switching it. So.
Okay, so let's back to the first question. Maybe David is already online. So, is it possible to create cross-section using the XF file?
Hello. I'm so sorry because my computer was suddenly broken and I can't do nothing for a few minutes, but I hope it will not happen now. So this is possible. We are in IDEA StatiCa, and we can input new cross-section. We click on the button Insert New Item, and here we go to Cold Formed Sections, General Shape. Then we click to Edit, and here we can select the XF file. I prepared for you one, so let's click on it. Here it is prepared, and confirm. And we select lines. And confirm. This cross-section was created. We confirm. Now we have to choose only thickness, for example 10 millimeter, or some radius for these parts. Oh, let's give 10 millimeter and confirm. And you can see that cross-section was imputed, and we can use it however we want.
Okay.
So that's it.
Thank you. And maybe the last question. The rest questions we will answer by email, so don't worry. So the last question on the joint design resistance, can you check all components, or does it stop? Or does it stop at the first failed part? Can you see which part failed? And I am assuming it was the weld on the example shown. David, can you comment this, or Philip?
Okay, I can. So the calculations stop in diagram when the weakest part collapses. So as you mentioned, the first failed part. Actually, as of now, we are not presenting the results for this higher ratio, but for 100%, and that's maybe something we can discuss. But definitely it is considered in the ratio which you get. If you place the, for instance, if I get the joint design resistance by 200% and I go for load effects and change everything to the 2 times as high, I will see the results in stress strain analysis.
Okay, thank you, Philip. So that's all for this moment. Thank you again for your time, and see you on the next webinars. As I said, All questions we will answer by emails. So have a nice day and goodbye.
Have a nice day as well.
Have a nice day.